This is section 1-1, day 1 after the video. We have a warm-up in exercise 79 to 82. Match the story with the correct figure. Figures are labeled A, B, C, and D. 79, as the blizzard got worse, the snow fell harder and harder. So it slowly fell over time, but as time went on, there was more and more snowfall. So this is letter A. The snow fell more and more softly, so it started snowing a lot, but as time progressed, there was more snow, but it was accumulating more slowly. So this is letter D. It snowed hard, but then it stopped. After a short time, the snow started falling softly. So this one, it started, stopped, and then it accumulated, but not quite as fast. So this is letter B. It snowed softly, and then it stopped. After a short time, the snow started falling harder. So here, the snow accumulated slowly, stopped, but then it accumulated much more quickly. So this is letter C. Checkpoint 1, plot the points -2, 4. So -2, 4 would be right here. This is letter A. B is 4, -2. So that's letter B. Letter C is -3, 0. And D, so this is C. D is 0, -3. So that's D down there. Checkpoint 2, graph y equals 4 minus x. Select integers from x, starting with -3 and ending with 3. So we have x and y. -3, -2, -1, 0, 1, 2, and 3. Now this is a line. This is linear. So we should expect a line from this. 4 minus -3 is 7. 4 minus -2 is 6. This is going to be 5, 4, 3, 2, and 1. So 7. And the reason that it's changing by 1 is because the slope is -1. So -3 is 7, and then the slope is -1. So it's all of these points right there. There's the line from -3 to 3. Not a great line. This tablet that I'm using is kind of tough to graph with. Graph y equals absolute value of x, and we're going to go from -4 to 2. So x and y, -4, -3, -2, -1, 0, 1, and 2. So -4. -4 plus 1 is -3, so that's 3. -3 plus 1 is -2, so that's 2. -2 plus 1 is -1, 1. That's going to be 0. 1, 2, and 3. So -4 is 3. -4 is 3. -3 is 2. -2 is 1. I'm off. I'm off by 1. I'm off by 1. Yep, let's try that one more time. -4 is 3. There we go. -3 is 2. -2 is 1. -1 is 0. 0 is 1. So we're going back up. 1 is 2, and 2 is 3 right there. All right. So there we have it. That should be nice and straight. Graph on a graphing calculator. All right, I can do that. Let's bring up the graphing calculator. Let's clear, I'm going to clear these out of here so it doesn't get in the way. Y equals x squared minus 2. So x squared, and then we'll minus 2. And it says -5 to 4 by 1s. And then -5 to 20 and go by 5s. So this is what the graph should look like right here. Let's see if that's similar to what I did and copy and pasted before. Looks exactly the same. Let's try this one. Y equals. Let's do absolute value. Absolute value is math and then num. Absolute value of x. And then plus 3. Window. -10 to 10 by 2s. -10 to 10 go by 2s. And then 0 to 20 by 5s. Let's graph that. There it is, that V shape when we graph absolute value. And there we have it. And should be exactly the same. I think that's the only one Only 2 on the page. There we go. Checkpoint 5, identify the x and y intercepts. So the x-intercept, here's our x-intercept right here. That's going to be -3, 0. The y-intercept is 0, 5. On this one, we have the x-intercept is none. And the y-intercept is 0, 4. That's up here. So 0, 4, y-intercept, where the graph crosses the y-axis. And then here, x and y-intercept is 0, 0. Divorce rates are considerably higher for couples who marry in their teens. The line graphs in Figure 111 show the percentages of marriages ending in divorce based on the wife's age at marriage. So there's under 18, this is over 25. Then there's 2 mathematical models that you can use to plug in years, and they'll spit out the percentage. So that is under 18, this is over 25. Use appropriate formula from example 6 to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. So 15 years under 18. So there's under 18. So D is equal to 4 times 15 years plus 5. That's 60 plus 5. That is 65%. Use appropriate line in Figure 111 to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. So under 18, and it says 15 years, and this is right at 60%. So this is 60. Does the given value by the mathematical model, that's this one right here, underestimate or overestimate the actual percentage of marriage ending in divorce after 15 years as shown by the graph, and by how much? So an overestimate by 5%.